Hi, we are going to be doing a survivorship lab where we're going to go out to a cemetery and collect information from the gravestones and use that to construct survivorship curves. I'm Sue Glenn, and this is for my ecology class. And I do have a lecture on survivorship curves based on the textbook we use. We have the textbook Ecology Concepts and Applications by Molles and Sher, the 8th edition, which was published by McGraw Hill in 2019. And I will put a link to that video at the end of this one. We're also using a lab kit that we got from Ecology Lab Kits, which includes the lab book that has the data sheets and the instructions for doing this lab as well. As I'm doing this, it's obviously pandemic times. I'm recording this from home. It's garbage day. If you hear some noisy garbage trucks go by, I apologize. And maybe there might be a cat purring or interfering as well. Survivorship curves are a really nice way to look at patterns in mortality in a population, and you can interpret what's going on quite quickly by looking at the curve shape. This picture in the background, this is a cemetery in Japan called Koyasan up on a mountaintop, which is pretty spectacular. We're going to use cemeteries that are for our data that are a little easier to read than the inscriptions on these ones. When you are making survivorship curves, you obviously need information about survivorship, and there's different types of data that you could be acquiring. You could get a cohort life table together where you look at everybody born at the same time, you keep records of them, and that way you know when they died, and you know that the control is they were born at all the same times, and you can see what their lives were like. That's really difficult to do, especially if they live longer than you. So that works for some things, but it is not what we're doing here. We're going to be doing a static life table where we have the age of death of individuals, and luckily for people we know that. For some organisms we do, for some we don't. Cut down a tree, you can count the tree rings, you'd know that for a tree, but if you have a dead ant, you're not going to know how old that ant was. Another way we do this is we look at age distributions when we're looking at probabilities of population growth and death, and you look at the proportion of individuals in each class. That's what the U.S. Census is doing. We'll be getting age distributions, and you'll be able to infer survivability from that, assuming that whatever caused people mortality in the past in different age groups is still consistent today. But we're going to be doing a static life table, and you'll learn how to set up a static life table in this presentation. Okay, so this is the goal. These are what survivorship curves look like. Across the x-axis, we have your age, and up the y-axis, we have some sort of measure of survivorship. And in often cases, we'll scale that to as if we had a population of 1,000 that we're dealing with. Just the numbers make it a little bit easier to look at the populations when you're not dealing with all of the different decimal points on there. And we get these different shapes to the survivorship curves. The survivorship curves have type 1 survivorship curves where really other than a little bit of juvenile mortality, you are going to have really high survivorship until you reach your ripe old age, and then you're gonna die. There are other organisms that have an equal survivorship or probability of mortality throughout their lives, and there are other organisms that really it's when they're small and young, their mortality rates are very high. But once you get past that, you can live to your ripe old age. So here's some examples. Most mammals end up with a type 1 survivorship curve. Most birds and small mammals and little lizards, doesn't matter how old they are, they're just as likely to be prey to a hawk at any age. And then you have invertebrates or that produce lots and lots of eggs, and then only a few of them survive, or something like sea turtles, lots of baby sea turtles, but once they get to a certain size, they're going to do fine. There goes the garbage truck again. So different organisms have different types of survivorship curves. One thing for you to consider when you're graphing your survivorship curve is to log the x-axis. You're going to be collecting your data from you didn't make a static life table, so you're going to collect your data from someplace you get the age at death, and that's going to be off of gravestones where they have the year that someone was born and the year that someone died. You can calculate their age at death. And You could also get this from historical documents, from death records. There's a number of ways we can grab this information. For this lab, I'm going to ask you to go out to a cemetery and look at the grave markers and collect this information on 30 different people who were born before the year 1920. So we want to make sure that we have a population that already, we would know that everyone in that population has already passed away. So we want people that were born before 1920. And you're going to determine their age at death by just subtracting their birth date from their death date. And we're just worried about years. Don't worry about the months, and that should get us close enough information. You might want to look around, see if there's some interesting historic cemeteries around you, and maybe you can find some pretty and interesting places to go and collect your data. So you're going to be looking at 30 people born before 1920. You're going to get take a picture of the cemetery sign, note where the cemetery is. If it's an interesting cemetery, you might want to make a note of that. This is a historic cemetery, which is a National Historic Register. It's a large black cemetery, the first black cemetery established in the Philadelphia area. And then we've got a data sheet in your lab book where you're going to put the names of the people, male or female. How are you going to know if they're male and female? We can usually tell from the name on the stone. Sometimes they'll only put initials, but then they will put son of, or husband of, or wife of, or daughter of, so that you can get more information from looking at the inscription. And if there isn't a way to tell whether it's male or female and get the gender, then just skip that one, go to another person. You're going to put down the birth year and the death year. Sometimes they just have the death year and their age, like they died at 78 years old on this date in 1872. So you can infer, if you just subtract the age from the death year, you should be able to put down the birth year. If you can't get the age, so you can't infer the birth and death, or if you can't tell if they were born before 1920, then just leave that one, move on to another one, and just be sensitive. There's people out visiting loved ones in the cemetery, and so you want to make sure that you sort of give them their space to spend time with the people that they miss. What I'm going to do is I'm going to show you how to actually add a form to Excel for your data entry. That'll make your data entry a lot easier. And we're going to actually add some data verifications, and that'll reduce errors in your data entry. And I think it's probably useful for you to learn how to do this. So all I've done to start with is I've just put the headings of the data that I'm going to put into Excel, which is from your data you got at the cemetery. So you have the gender of each person, the year they were born, the year that they died, and then we'll calculate age. And first thing I'm going to do is I'm going to turn this into a table. So I'm just going to click on it, and where it says format as table, I'm just going to pick the light format. My table has headers. And I'm actually even going to pick the lighter style like that, so it doesn't have any dark lines or anything on it. And under the word age, we're going to be calculating in this one. So that's going to be equal whatever is in the death column of the year of death minus the year of birth. And that should give us the age of the person. Now, we're going to be using the forms tool in Excel. And even though you have it in Excel, it's not anywhere in your menus unless you've already added it to your menus. And so what you're going to do is you're going to go to File. Down at the bottom of File, you go to Options. Click on Options, and we're going to do Customize Ribbon. Actually, I'm going to customize the Quick Access Toolbar. The Quick Access Toolbar is the one right up here on the top, and that way you find it quick and easy. So go to Quick Access Toolbar. It's not a popular command. It's go to All Commands. You scroll down till you find the word Form. It's right there. You're going to click on that and you're going to add it. And I've already done that. I've already got it up there. But click on Form, click Add. It'll appear over here like this. And then you're going to click OK. And then you're going to have this little thing up here called Form. So I can click anywhere in my table now. I've got this little table here. And I click on the picture Form. And now a form comes up. And I can enter my data into this form. So I can put M or F for the gender, tab, or click on the year of birth, and I can say this person was born in 1852. The year of death, I can say was 1925. And I hit enter, and it's now added the table data in, and it's put in an age for it, calculated the age. And then I can go into a female. Say my next one was 1855 and died 1932. Click enter, and it calculates the age of death. So that's fairly straightforward. It's easy to do. You can put your data in. And I'm going to also teach you how to verify that you're putting in your data correctly. And the way I'm going to be doing that is I'm going to click on, well, first of all, I'm going to make sure that my year of birth and my year of death are listed as numbers here. So they're listed as numbers, which is what I want them to be. I want those guys to be numbers. And then I'm going to go over here to data. I'm just going to go on that, click on any cell in the year of birth. I'm at data. In data, I'm going to go this little weird looking thing. It's called data validation. And I'm going to pick data validation. And we're going to make a rule. And we're going to click on settings and say, okay, this is a whole number. And we want to make sure that it's less than, you got a whole choice of things, less than, whole number, less than. And our rules were that we didn't want any people born after 1920. So I don't want it any higher, any bigger number than 1920, right? So I actually put 1921 in there as the beyond the maximum, right? So it's going to be less than 1921. I can also put a little error message here that births must be prior to 1920 and click OK. So now let me put some more data in. Remember, I go back up to forms, just click on it, the form pops up. I'm going to put in a new piece of data. Let's say I put in a female who was born in 1950 and died in 1990. And I hit enter, and it says, nope, you can't do that. It doesn't match our data restrictions for this cell. Retry. And I look at my data. Oh, no, it wasn't 1950. And that one. And there we go. We got it came in, it worked for 1920 because I put the year as 1921. We can do the same thing in the death column. So we can click on our data verification there, data validation there, and you can see it's going to be a whole number. It's going to be less than, and I want to make sure it's no larger than 2020, right? Actually, we'll put 2021. That way, the 2020 numbers will work. Error alert, death date is in the future. And click OK. So now, if I put in, let's say, okay, a new one. So let's say I put in a female, and I put the year's birth as 1994, and I put the year of death as 2080, and hit enter. You see, it's not gonna work. So the year of birth was wrong, and the year of death was wrong. So let me pick my next one. Let's say this next one is a male, born 1880, and let's say died 2050. Hit enter. No, death date is in the future. Try again, retry. Oh, I did that wrong. I meant 1950. 1950. Hit enter, and it'll go in. And hit close, and something's gone wrong here. I missed my year of birth and my genders on these ones. So how do I fix that? Well, let me go back, and I'm going to go take a look at what I've done wrong. So number 1's right, number 2 is right. Oh, look, I'm missing the gender on number 3. I can put in female there. And number 4, missing the gender, and somehow I was missing the birth date on that one. And hit enter. And now it put them all in here. I can also go in, close this. I can also go in and edit the data set myself. So once you've got that set up, you can type in all of your data, and then I'm going to show you how you can use that data to make a life table. Now, in order to make a survivorship curve, we can actually go through and make a life table. So I've gone ahead and I've put the columns for the life table across here. So we've got the minimum and maximum ages in each age group. We've got the number of deaths, the total deaths, and we've divided that into one part of the table is going to be about females, one's going to be about males. So we've got female deaths and male deaths, and then we do these calculations. Now, in order to get the ages in each cohort in each age group, we could go through and manually count them up and then see how many of those are males and females. That's time consuming, and when you're manually doing something, you often make mistakes doing it. So we're going to learn how to use the COUNTIFS statement in Excel to count it for us. Count statements in Excel are handy, and the COUNTIF, it lets you set a criteria. The COUNTIFS, the COUNTIFs, lets you set several criteria so that we can say we're looking for females over the age of 5, less than the age of 9.9, and the females, not males. So we can set all those criteria. So we're going to be using this rather complicated looking statement here, but it's going to make our life a little bit easier. So the first thing I have to do is set up my age cohorts. So I'm going to start with the children between 0 and 4.9 years of age, those young kids that died within that age group. Now my next cohort is going to just be 5 years higher than that. So I'm just going to go equals, click on the box above, and add 5 years. And I'm going to do the same thing with the maximum. And then I can just take these 2 boxes that just are adding 5 years, and pull that all the way down so I can get to my maximum age. And my maximum age was 110, so I make sure I've got that covered. And just as we're working through these things, I just wanted to point out I've got my data table in columns A to D. So I've got the age in D and the gender in A. And all this is the year of birth and the year of death. And I've just, to calculate the age, I just subtracted the year of birth from the year of death from the year of birth. And then I put in a blank column, and then I started my life table. But if you've got stuff in different columns, you'll just have to adjust your equation for that. If you get stuck somewhere, if things are not going well, you can send me your spreadsheet. You can ask a question. We can get on Zoom and take a look. It's like solving puzzles sometimes to figure out where it's going wrong. Now, to add up these deaths, to total these deaths for people within this age group, I'm going to use this COUNTIF statement. So I'm going to say equals COUNTIFs, and then I open the parentheses, and I've got to put in all these different criteria. So the first thing it wants to know is where am I looking for these criteria? I'm looking in the ages because I'm looking between the minimum and maximum ages. So I'm going to look at these ages right here. Oops, I didn't quite get them all. So I'm just gonna type in here. Goes down to D2 to D51, and I want them whenever it's calculating it, I don't want it to shift down this column, so I'm just going to make sure we stay in the right column, column D, and we stay within the right rows, which is 2 to 51. So I'm just putting these little dollar signs in here to make sure that happens. And then I put a little comma here, and then my criteria is I'm looking for people that are less than 4.9. So it's actually going to be less than or equal, and put my little quotes. And I need to link this with this ampersand to the actual value I'm looking at, which is this one right here that's in G2, which is the maximum age within that cohort. And I want to make sure that whenever I'm looking at females and males, I don't skip columns or anything. So I'm just going to stick a little dollar sign on the column. But when we go down, I want the next row to look down at 3 and 4 and 5. So I don't put a dollar sign on the 2. So that will give me how many people who died that were less than 4.9. But I don't really need to worry about the minimum in this particular one, but I'll need to worry about it in all these, so I might as well just get it in here now. I'm going to look in the same age column, so it's $D, $2, $D, $51, so the same age column, and this time I'm looking for greater than or equal to, and then it's going to be what we have in the F, greater than or equal to, so it's going to be ampersand, and I'm looking dollar sign F2. Yeah, now it's looking in the right place. Close the parentheses, and there's 6 deaths. So if I went through this age column, I would find 6 people that within that age range. Now, I don't want to take all the time to type that out on every row, but luckily the way we've made it, it'll slip down to every row and get you the number of deaths in each one. So now, we could look at a survivorship curve for everybody, but I want you to take a look at, you could compare the females versus the males, kind of gives you a hypothesis to test. So in order to do the females, I'm going to add another term in here, and that term is going to be looking through the gender column, column A, and looking for the ones with Fs for females. So I'm going to use my same equation, so I'm just going to copy that over there. But now I'm going to add to it. So I'm going to add another criteria. And you can keep adding criteria to these if statements. And so now instead of column D, we're going to look at column A. So I'm looking at A2 to, oops, $A, 2 to A51. And in that, I put a little comma in that. I'm looking for where it equals F. Just simple. Equals female. So now it tells me that 4 of those 6 deaths were females. And I can go ahead and get all the female deaths then in each age group, all the way down. I can do the same thing again for males. All I have to do, I just copied that over here. It looks like it's 4 deaths, but I still got the criteria as being females, and replace that with M for males. And then, so 2 of the deaths were males, 4 of the deaths were females. And now we've got that column. We want the total number of males and the total number of females, so we're going to sum each of these columns. So you can type in equals sum and then highlight the values that you're adding together, or I can use the little sum function up here and manage to get the right thing. I also want to name these as constants. So I've called this one Sum Females 2021 because, and you can't put any spaces in the name that you put into the name box. And I called this name box Sum Males 2021 so that we can always find that constant again. So that's my total females for 24 and my total males for 26. To get the females surviving at the beginning of each age group, well, we start with the total number. So there were a total number of females born. And then within the first age group, we lost 4. So by the time they reach the age of 5, we're going to have to subtract that 4. So I'm going to go equals. I'm clicking on the number I had in the age group before and subtracting the number that died. And so now I'm down to 20. And then since I put this as an equation, I can drag that all the way down. And then we have, so we can look at any age group, say the age of 60, 14 out of the 24 were still alive. And you can do exactly the same thing for the males. You're going to start with the number of males total you had. But then we're going to take that and subtract how many died. And then I'm just dragging that down. Now, in order to get this as a proportion of the total population, I'm just going to take how many are surviving and divide it by how many we started with. And that gives you a proportion. So if I drag that down, so if I look again at the age of 60, that 0.58 were alive, still alive at the age of 60. So that's 58% of that population. And we can do the same thing over here with males. So we take the number in this column, divide it by the total males to get the proportion. And then we pull that right the way down. This is so much faster than doing all this by hand. Now we can see these proportions, they're kind of messy. They are lots and lots of decimal points, and that's why we do these 1000 standards. So we will just take whatever we've got in our survivorship column and multiply it by 1000. And that will get rid of all of those messy decimal points. And on some of these, if you still have decimal points, you can adjust it. So I can take away decimal points. I can add decimal points back in. But I I've got them all taken away now. And I can do the same thing over here. That's going to equal that times 1000. And this is what we're going to graph. We're going to graph these male and female survivorship 1000s at the different ages. So in order to graph those, I'm going to use the minimum age, so at the beginning of the cohort. So I'm going to highlight that, and then holding down the control, I'm going to get my female 1000s and my male survivorship 1000s. I'm holding down control to select all these, or you can copy and paste them into a new table and then graph that if you want. Then I'm going to insert scatter plot. I'm going to put lines on it. You see, you've got these choices here. I'm going to do a scatter plot with lines. And then I'm just going to clean up my scatter plot a little bit. So my title, this is going to be an example, but I would put the location, and these would be born before 1920. So I've got my title sitting on here. I need to add my axis titles. So this is Survivorship 1000, and this is going to be age. You can change the colors on these things. So I've got my males are sitting here in orange. Well, I could turn them, nice blue color. The females, I can turn whatever colors you like. I'm not going to take a lot of time on this. I can make them a orange color, or you could make them pink, whatever you want to do. Make them red, orange, whatever. And then that way you can tell your lines apart easily to see if there are differences. And as I said, this is made up data. You can also adjust your axis. So the x-axis age, I might want more detail in that. I can right click. Well, for one thing, it's going up to too high and off maximum. So format axis, I can make my maximum. They didn't go older than 110. I can adjust my units. Right now it's every 20 years. I can make it every 10 years. So I like that. I can format this axis because it's going up to 1200 and it should only go up to 1000. So you can adjust your axis. You can make it look how you want it to look. And you can take these lines off however you want to make it look pretty. And then that is it. That's done. We've got our scatter plot of survivorship. If you wanted to go ahead and make any axis on a plot, you can make the axes, format axis. You can make logarithmic scales on them too. You can see you could click on that or put them in the reverse order or other weird things. We're just going to leave this as it is right now. Stop right there. Okay, you learned how to do a lot of really useful things in Excel. You added forms to Excel. I've given you a link to a really good YouTube channel where she has a video where she's showing you how to use forms. You learned how to add data verifications to your forms. You learned how to use the frequency function. We used the name box. We managed to figure out how to set up a life table. One of the things I needed to fix on that previous video on the previous slide, I needed to plot the x-axis or the y-axis, the survivorship on the graph, as a log scale. And here I fixed it right here. And actually now it looks like a type one, survivorship curve one. So I put the log scale in, and all I did was right click on the y-axis and change the scale of that to a log scale. I also should have put my axis title on here. Seems to be missing. What you're going to be submitting for my class, you're going to be updating your blog, putting your cemetery information, describe the cemetery. There's things that's going to affect the shape of that curve, like if it's a military cemetery, you're going to put in your table of your survivorship in the different age groups, and you're going to put in your scatter plot. And I also have for my class a small assignment in e-learning where you have to submit your Excel sheet and just describe your results. And don't leave your laptop in the cemetery. This guy left his in the cemetery, and when he went back to get it, he found it was playing creepy music and decided to get rid of it and sold it on eBay for a pretty penny. So maybe leave it in the cemetery. Up to you. But make sure you get your assignment submitted before you do. And thank you for joining us. And put the link to the survivorship lecture right here.